day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidi Sokongwani. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Grade 12, today we will be looking into differential calculus. Specifically, we will be doing cubic function sketching and interpretation of the graph. Remember, our WhatsApp number is 079-578-2908. You are more than welcome to send your clarity-seeking question to that particular number or any alternative solution that you want to share with us as we continue with the lesson. And then objectives of today's lesson: after the completion of the lesson, you will be able to sketch graphs of cubic polynomial functions using differentiation to determine the coordinates of the stationary points. Secondly, you will be able to analyze the information, make deduction, read values or intervals from your graph. And then with the cubic function now, when you are sketching a cubic function grade 12, you must be able to identify the shape of the graph. And the shape of this graph depends on the value of A. And then where do we get this value of A now? From the original equation, of which is y equal to ax cubed plus bx squared plus cx plus d. And then we have a condition there that A cannot be a zero, because if this A can be a zero, this will turn into a parabola or a quadratic function instead of a cubic function. Right, grade 12. Now we are talking to this A value here, of which it determines the shape of your cubic function. If that particular A value is greater than zero means what? If the value of A is positive, that means this is the shape that we are expecting. If not that one, it will be a smooth one like the second one there, depending on the equation given to you. And then if the value of A now is less than zero, that meaning that it is now negative. That means grade 12, we are expecting the shape that is end up being facing downwards there, facing downwards if it's a smooth curve like that. And then if it's a positive one, you can see that the part that is ending on your right hand side, it will be a positive part. Okay. Now that means this value of A plays a major role in terms of the shape of the graph. And then looking at the y-intercept, you know in all your function, in order to find the y-intercept, you let x equal to 0. Then if your function is in the standard form of the equation, that means if you let x equal to 0, this x will be 0, that one x, 0, 0. So you'll be left only with the d there, because everything here will be 0 now. So that is why we say now, if we let x equal to 0, then y-intercept will be equal to d. When coming to the x-intercept, you let x equal to 0 greater, as you do with all other functions. And then with this one, we are going to use your factor theorem to factorize, to find the factors of this cubic function and to solve for x. We are depending on the factor theorem. Remember, you did the remainder theorem and the factor theorem, but for this function, we are focusing only on the factor theorem. And then after using factor theorem to identify one factor and then factorize the trinomial formed after that, you can now solve for x. That is the procedure to find your x-intercept. After y and x-intercept, you can now look at the stationary point. What do we mean by stationary point? We are referring to the turning points of this function. As you can see now, if you are having the positive one like this, you will be having the maximum. The highest turning point is maximum, local maxima, and the local minimum there. Then this is the minimum turning point. The highest is the maximum, the lowest turning point, it will be the minimum. That means these are the stationary points. We have two of them because it's a cubic function, unless where you are having a smooth curve like that one. We are going to go through activities called grade 12 so that you can check what is happening between your maxima and minima value and why are we having such a smooth curve there instead of having those two stationary points. And then how do you calculate the stationary point? You determine the derivative of your f at x function there. Okay, the derivative of your f at x function. You derive your f at x function, differentiate that, and then that derivative, you let it equal to 0. The derivative that you have determined there, you let it equal to 0. And then you solve for x. After getting the value of x to x turning point, you substitute them into the original equation, original that was given to you for that particular function, and then to find the value of y. Then you can now solve for y. Substitute x turning point into original to get the y turning point. Then alternatively, they will give you the two stationary point maxima and minima. Now we are having three conditions now under the cubic function x-intercept. We have a function that is cutting the x-intercept at one point, like that one. That means you'll find that the values for other x-intercept, they are non-real or they are imaginary. So this allows you only to find one x-intercept. As you can see, it is cutting the x-intercept only once there. And then now we have a condition where it has two intercepts. X-intercept, as you can see, it is cutting there, and then this one, it's cut. It's the x-intercept. It is also a stationary point for this particular graph. It's a maximum turning point there, as you can see, and this one will be the minimum. So now we will also look at that. What is causing this to be only one x-intercept? What is causing that to have only two? Whereas we are expecting it to have three x-intercept because it is x to the power 3 function. So this is the basic one where you are having all your three x-intercept. So these are the possible x-intercept that you can get on the cubic function. Now let's start with the first activity. We are given that f at x is equals to minus x cubed plus 4x squared minus 4x. The first question, it says write down. That means if it says write down grade 12, the answer is on the given information. No need to calculate. And then they say write down the coordinates. If they say coordinates, they need that in the form of x and y, okay, of the y-intercept of f. Okay, write down the coordinates of the y-intercept. Now, remember previously as we were looking at the steps that you do when you sketch your graph, we said when you determine the y-intercept, you let x equal to 0. We are looking for the y-intercept. We're gonna let x equals to 0. So if x is 0, that means grade 12, we are going to put a 0 here, plus 4 into 0 squared minus 4 into 0. So you can see the 0, 0, 0 there. So now if you look at this, as long as you see x everywhere, that means now your y will be also 0 there. When you substitute x0, you get y0. So because they need this in coordinate form, x is 0 and the y is 0. That is the coordinate you are looking for there. And then 1.2, determine the x-intercept of f. We know that when you look for x-intercept, we let y equal to 0 now, vice versa. X-intercept, we let y equal to 0. Remember this f at x here, it stands for y, okay? So now if we are letting this to be 0, then it will be 0 equals to minus x cubed plus 4x squared minus 4x. And then grade 12, as you can see now, with this one, it's very easy because you are having a common factor, x there. So we are going to take out this common factor as minus x. So this minus x cubed divided by minus x, it will be positive x squared. 4x squared divided by minus x, it will be minus 4x. Minus 4x divided by minus x, common factor, it will be a positive 4. Can you see grade 12? We have now created a trinomial which is quadratic. And then now here we can say this x now is equals to 0, because negative x equal to 0 divided by negative, we still have x equal to 0. So that we can deal with the factors of this one now. Your trinomial there, it is saying we are looking for factors of 4. When you add them, they must give you a minus 4. So factors of 4 are 4 and 1 or a 2 and 2. It's either you multiply 4 times 1 or 2 times 2 to get a 4. But in this case, we are looking for a negative 4. When you add, they must give you negative 4. There's no way you can take this scripture because 4 plus 1 is 5. So we are left with this option here. That is the correct one for this trinomial. So factors will be 2 and 2. And then they must both be negative because we are looking for negative 4. Both negative because we are looking for negative. And then remember, a negative times a negative is a positive. But when you add them, minus 2 plus a negative 2 will give us a negative 4. When you add, you get a negative. When you multiply, it gives you a positive. Those are the correct ones, grade 12. Let's continue now. If you look at these two brackets, they are giving you bracket of the same thing. This is two brackets of the same thing. Therefore, it will give us the same x value, which is x equal to 2. There's no need to repeat x equal to 2 and another x equal to 2. X equal to 2 is enough, grade 12. So now let's look at the mark allocation. The first mark is for letting y equal to 0. Second mark for common factor and your trinomial. And then the third mark will be for the x value equal to 0. The fourth one for the x equal to 2. So your intercept there will work 4 marks. And then 1.3, determine the stationary point of F. Now, we are looking at the stationary. Remember, we said the stationary point will be calculated by differentiating your function. Step number 1. Number 2, you let it equal to 0. Number 3, you solve for x. Number 4, you substitute x into original to get the y values. Those are the 4 steps to follow for stationary. Let's start now. We are differentiating f at x. It will be f derivative of x equal to 3 times minus 1. It's minus 3x. Subtract 1 from the exponent to the power 2. And then 2 times plus 4 is plus 8. And then 2 minus 1 is x to the power 1. And then now if it's minus 4x to the power 1, your differentiation will be minus 4 there. Okay, and then you let this equal to 0. So this side we can multiply by negative throughout to get rid of this negative here, so that we can factorize a trinomial that is positive. That is 3x squared minus 8x plus 4. Grade 12, you are also welcome to use your quadratic formula if you are not comfortable with factorizing using brackets, because you do a lot of mistakes most of the time, grade 12. So go for your quadratic formula. It is also acceptable there. Okay, and then now let's continue. This will give us a 3x as the first factor there, multiplied by another x on the next bracket. And then now we are looking for factors of 4. Remember, 3 is having impact on those factors. When you add them, they must give you a -8. That means they must both be negative now to give us a positive. When you add, give us a negative. So now we are taking 2 and 2. We can check grade 12. It will be 3 times -2, which is -6x. And then -2 times x, which is -2x. Yes, this will give us a -8. Our factors are 100% correct. And then from here now, for the first bracket, 3x will be equal to 2, or second bracket, x is equal to 2. This side we are dividing by 3, both sides. Therefore, x will be equal to 2 over 3. These are the x turning point. Remember, stationary, we must calculate for both x and y because they are coordinating to the stationary point. So now, grade 12, you are going to take your first x value, substitute it into original there. That means you'll be having f at 2 over 3 is equal to -2 over 3 to the power 3 plus 4 into 2 over 3 squared minus 4 into 2 over 3. And then now punch into your calculator. This is giving us -1,19. Okay. And then we also look at the second one, f at 2. And then this will be minus into 2 now, cubed plus 4. We are now substituting x with the 2, minus 4 into 2 into your calculator to the answer. This is giving us a 0. You know why? It's because we have these 2 again as the x-intercept on our previous calculation. You remember those 2 brackets which were repeating x minus 2. The brackets are already telling us that that x value is a turning point. That is why it is giving us 2 brackets of the same thing. Hence, we are having again the bracket of x minus 2 here at the stationary point. Do you get the relationship? I hope, grade 12. And then now let's conclude our turning point. The first one will be x2 over 3 coordinating with -1,19. The second one will be 2, positive 2 coordinating with the 0 there. And then now, grade 12, after calculating your stationary points or your turning points, indicate which one is the maximum, which one is the minimum. It will assist you when you are sketching your functions. Now, how do we do that? We compare the y values of your turning point. Which one is bigger now? 0 is bigger than -1, -1,19. So 0, since it's bigger, it will be the maximum turning point. And then this one, because it's smaller, it will be the minimum turning point. Then these are your turning points, grade 12, identified as being maximum and minimum. Let's continue with our activity. And I hope we are still together. And then the next question, 1.4, sketch the graph of f. Clearly show all your intercepts. Okay, remember we have calculated the y-intercept previously. We said y is equal to 0. And then we calculated the x-intercept where we have x equal to 0 and the x equal to 2. We have just calculated the stationary point, 2 over 3 alternating with -1,19. Another one being a 2 alternating with a 0 there. And then we said this is the minimum and the maximum turning point. Grade 12, if you look at this, you have y-intercept, you have x, you have stationary. There is one thing missing before you sketch. Identify the shape. So what is the shape of this graph? Our a value is less than 0, meaning it is negative. That means we are expecting a graph that starts being concave down and then, concave up and then down. Therefore, it's a negative graph. Or it can be a smooth curve like that. That is the expected graph before we can draw You must have all those 4 conditions. Okay, now you can now sketch your graph. We have everything that we need. We can now sketch this graph. So now we have the y-intercept at 0. That is the y-intercept. We have x-intercept at 0 again, and then also at 2. That is the intercept. And then we have the turning point at 2/3. 2/3 is 0. It's before 1. That means it's somewhere here, 2/3 before 1. That means that 1 is not an intercept, it's a turning point. It turns at 2/3, alternating with minus 1,19. So you look at the alternating point for the 2. Where they meet, it is your turning point. And then we have another turning point at 2 and 0. So this point is our turning point. Remember, this one is the minimum one. It is where you'll be having this shape. And then 2 and 0 is the maximum one. Can you see how does it assist you, greater? And then now you can join your points now and have your graph. So this will be your cubic function. Check the shape, is it correct? Yes, because now you end up having the negative part on your graph since A is negative there, less than 0. So this is the sketch expected from you, graders. Okay, and then 1 mark will be for the intercept, 1 mark for the shape, and then 1 mark for the stationary point. This sketching with 3 marks. And then move on to activity 2, another type of your cubic function. In this case, they have already factorized for you. It is still an x cubed because it's 1, 2, 3x there. Okay, then it says write down the coordinates of the x-intercept. Why is it saying write down? Because they have already factorized for you. So now 2.1, we are looking for the x-intercept when y is 0. So the first x-intercept in this case, if we let this part be 0, we are having x plus 2, x minus 1, x minus 3. Then the first bracket here will be x equal to minus 2, or second bracket x equal to 1, or the last bracket x equals to 3. Those are the x-intercept greater. Then you'll have 1, 2, 3 marks for that. Okay, if they need this in coordinate form, it will be minus 2 and 0 for this one, 1 and 0 for that one, and then 3 and 0 for this one. Those are the coordinate form. Coordinates needed with x and y. Why are we putting 0 on y? Because we let y equal to 0 there. So y will be 0 for all the x-intercepts. Okay. 2.2, determine the y-intercept of this function. Now y-intercept, you let x equal to 0, same method as previous question. And then now we let x equal to 0, our y, remember h at x here stands for y. So y is equal to, let x equal to 0, 0 plus 2, 0 minus 1, 0 minus 3. We are substituting into that equation, grade 12, where we have x, we are now putting a 0 there. And then now into, you can use your calculator straight and forward, it's fine. Or you can simplify 2, the first bracket minus 1 and minus 3 for the second bracket. Then this will give us positive 3 times 2, which is a 6. Therefore, our y-intercept is a 6. If they need it in coordinate form, x is 0 and y is 6. That is the coordinate form of that y-intercept. And then now 2.3, we are on the same question. Determine the stationary point of this function. Look at the equation, grade 12. Remember the rules of differentiation. you cannot differentiate when you are having brackets. You need to multiply them out. Take this equation back to x cubed. It is only then that you can differentiate. We are not differentiating the bracket. The rule does not allow us. So the first thing that you'll be doing is to simplify this bracket here. Okay. So we are having h at x. Then I'm going to leave the first bracket and start with the next two. So when you are multiplying, it will be x times x, which is x squared. And then x times minus 3 is minus 3x. And then this one minus 1, it will be minus 4x. And negative 1 times negative 3, it will be a positive 3 there. Then I am bringing in x into each term. X times x squared is x cubed. X times minus 4 minus 4x squared. X times 3, that is 3x. And then now we come to 2 now. 2 times x squared plus 2x squared. 2 times minus 4 minus 8x. 2 times 3, that is a 6. What is the next step, grade 12? We now look at the like terms. So x cubed is the only one there. And then we have the minus 4x squared plus 2x squared there. It will give us the minus what, grade 12? 2x squared. And then we have plus 3 minus 8x, which is minus what? 5x. And then this constant value, that is the only one we have. We can't add anything to that one. So that is our h at x function back to its original form of equation. And then now we can now differentiate this h derivative of x. It will be 3 times 1, which is 3x, subtract 1 from the exponent to the power 2. 2 times minus 2 minus 4x, subtract 1 to the power 1. And then if it is minus 5x to the power 1, you take the coefficient as your derivative, then it's minus 5. A constant derivative is 0. So we know there's a 0, there's no need to write it, grade 12. And then we let this derivative be 0. And then now we need to factorize this bracket here. And then if you look at this, we can't find factors of 5. When you subtract, give you 4 with the impact of that 3 there. So it's a forced, grade 12, that you use your quadratic formula. You are forced to use your quadratic. Do you still remember your quadratic? Let's put this first with the 0 there. Minus 4x minus 5. And then now we go quadratic. X is equal to minus b plus minus b squared minus 4ac all over 2a. Remember this quadratic formula. Please double check from your formula sheet at the back of your question paper that you have copied correct, grade 12. And then the value of b is minus 4 there. Then it will be negative from the formula there. And then the minus 4 from the equation. And then now plus minus the square root of minus 4 squared minus 4. A is positive 3. And the c is minus 5 there. Everything into the square root sign. And then divide by 2 into a. Our a is 3 there. Get straight into your calculator, put everything. Do not do it partially like that. And then it will give you a simple set form 2 plus minus the square root of 19 over 3 there. And then now we can now identify the values of x to 2 decimal places. The first x turning point there will be 2,12. Into your calculator, SD button or the change button on your sharp calculator. And then now, then another x turning point value is x equal to negative 0,77. Please ensure your rounding off is correct. Remember, at the beginning of your paper, you are having the instruction sheet that is telling you you then round off all your answers to 2 decimal places unless stated otherwise. If there are no conditions, everything must be to 2 decimal places. Rounding must be correct, grade 12. Remember, if a number that follows is 5 up, you add 1 to the previous one. If it is 4 less, you don't add anything. Now we are having the x turning point values. Do you know what to do next, grade 12? I hope you know now. We need to find the y values. We are going to substitute these x values into original to find our y. Now, the first one will be h at 2, 1, 2. X will be 2, 1, 2. And then this is 2, 1, 2 plus 2 for the first bracket here. And then followed by 2, 1, 2 minus 1. 2, 1, 2 minus 3, and then into your calculator straight to your y value, grade 12. This gives us minus 4,06. I hope we are together. That will be the first y turning point. And then the next one will be at h equal to minus 0,77. So x is now minus 0,77 plus 2 for the first bracket, followed by minus 0,77 minus 1 second bracket. The third bracket is minus 0,77 minus 3. And then this one is giving us the y value of 8,21. So now let's write this in coordinate form now. If x is 2,12, the y value will be minus 4,06. And the next one, if x is minus 0,77, then the y value is 8,21. Grade 12, can you now identify which one is the maximum and the minimum turning point? Remember, you identify using the y turning point. Which one is bigger? 8,21. Therefore, this will be maximum. Okay? And this will be the minimum turning point of your graph. I hope everything is clear. Grade 12 up to this part. And then now continue to the next one. Sketch the graph of h. Number 1, you must know your shape. That is very important. All your x values are positive. That means this is a positive function. A is greater than 0. Therefore, the graph is positive. So if it is positive, you are expecting a shape like that or a smooth curve like that one. That is the first thing, shape. Secondly, you need your y-intercept when x is 0. So now we have calculated the y-intercept on the previous, and then we have found that our y is equal to 6. Previously, grade 12 on your 2.1, 2.2. And then now we look at the x-intercept. We have already calculated that when y is 0, the first x-intercept is x equal to minus 2. And the other one is x equals to 1, followed by x equal to 3. Remember, we determined that using those given factors there. And then thirdly, this is number 3. Number 4, the last one, the stationary point, of which is your turning point. We have calculated the first one as minus 0,77 together with 8,21 as y value there. And then we said this is the maximum. Do you still remember that? And then now the x value, second turning point, is for x value 2.12, alternating with minus 4,06. That is your second turning point. Since this one is smaller, that will be your minimum value. And then grade 12, you have all what you need before you sketch the graph. I can't just go straight to sketching without ensuring that I have all that I need before sketching that particular cubic function. Now we can now sketch the graph. We have y equal to 6 there as our y-intercept. And then now we have x equal to minus 2. as our first x-intercept. You have x equal to 1. As your x-intercept, you have x equal to 3 as your x-intercept there. And then now let's address the turning point. Minus 0, 77 is before 1, minus 1 there. Minus 0, 77. This is alternating, it's a pair, they go together. 8,21, then we have 8,21 there. They are alternating. Where they meet, now we have a point there. Okay. And then now we have 2,12. Immediately after 2 here, we have 2,12. And then this goes with minus 4,06. Where they meet, they form a point there because they are coordinating. Now, remember we said 8,21 is our maximum turning point. And then the 2,12 and minus 4 is the minimum turning point. Start by indicating those turning points, they will assist you. And then now let's sketch the graph. Now we are turning there, we go to that x-intercept, we go this way, passing through the intercept there, come to the stationary turning minimum there, to the x-intercept upwards. Now you compare your shape together with this one. Is it correct? Yes, 100% correct. Great job. So your first mark will be for the shape, the second mark for the x-intercept, the third mark for the y-intercept, and the fourth mark will be for both stationary points to be correct. That is the 4 marks allocation for the sketching of this particular graph when it is 100% correct. Moving to another type, now notation. We are given g at x minus x cubed plus 6x squared minus 12x plus 16 as our g at x function. Number 1, you need to write down the coordinates of y-intercept. And then remember, you let x equal to 0. What will be left? Because if you let this be 0, everything here will be 0. You will only be left with 16. That means your y-intercept, when x is 0, your y will be equal to 16. That is 3.1. So you have 1 mark for that. And then the 3.2, determine the x-intercept of g. This is a very long journey, great jobs now. It is where we are bringing in our factor theorem. Why? Because we don't have any factor that we can use in order to factorize this particular cubic function. Now, number 1, 3.1, they say write it this in coordinate form, so it will be 0 and 16. I hope you know that. The safest way is to write all your answers in coordinate form, whether the examiner has indicated or not, so that you get a practice of answering your question up to that maximum level. Okay. And then now the x-intercept of this, we are having the g at x function. You know, when you are looking for x-intercept, you let y equal to 0. Our y in this case is g at x. So we are going to let that equal to 0. And then this will be minus x cubed plus 6x squared minus 12x plus 16. So grade 12, we can't factorize with a negative on x cubed. You are going to multiply throughout with the negative. Then this will be x cubed minus 6x squared plus 12x minus 16. And then from there now, we need to find one factor that will assist us to find other 2 factors of this. So how are we going to do that, grade 12? We are going to substitute 1, minus 1, 2, minus 2, 3, minus 3, 4, minus 4, continuously so into this g at x function until you get, it gives you an answer 0, until you get a 0. The minute it gives you a 0, that means it is telling you that that particular number that you have used there is a factor of this cubic function. Okay, now testing with me. test, and then now check. If we are checking, we end up finding that G at 4 is the one that is working for this particular expression. If you put 4 there into this equation, this is giving you a 0 there, okay? Therefore, we can conclude that x, remember you have substituted a positive 4. That means now if we take this back, remember it is x equal to 4. When you take it back to the side, it will be x minus 4. Hence, we are writing it as x minus 4 is a factor of this cubic function. Happy grade 12. We now have the first factor, of which it will assist us to get the other two factors. How do we do that? We are going to write down our first factor, x minus 4, and then now we open a bracket for the trinomial. So now I'm having the method, they call it inspection method, but I find it well if we call it the short method of finding these values now. Others are using synthetic division, it's fine. As long as we are comfortable with whatever method we are using, it's okay with me. Others are using synthetic, others are using long division. I am going to now show you this short method that can also assist you to find the factors without making a lot of mistakes. Because with synthetic and long division, you make a lot of mistakes in terms of the signs, they being negative or positive. So with this one, you take the first term, of which you are taking that x cubed, okay? That is the first thing that you are doing. You're going to divide it by the first x, okay? And then that will be x to the power 2. And then now this will be your first value in your bracket then. And then the middle one, always we don't know. That is what we are looking for. We let that be px. Always grade 12, let that be px. And then now step number 2, we take minus 16, the last term there. We divide by the next term there, which is minus 4. And then this will give you a 4. Then now that plus 4 is the one that we are adding into this. So if you look at your trinomial now, you need only one value, which is b there. If you can get a b, that means you are done with your factorization grade 12 to get the trinomial. Now, how do we get this b now? To find a b, we are going to multiply this minus 4 by x squared will give us minus 4x squared. And then x by bx will give us bx squared. And then now we are going to add these two. We only do those first two, okay? And then now we are having minus 4x squared plus bx squared. This will be equal to the x squared in your expression, in your equation there. This will be equalized to this minus 6x squared. Okay, we are looking for bx squared. The minus 4 to the side, it will be positive 4. Then minus 6 plus 4, you have minus 2x squared. Therefore, the value of b is what, grade 12? It's minus 2. We only need the value of b. Forget about the x squared. X squared is assisting us to find this b value. We are happy now. We have the value of b being minus 2. We can now go back to our x-intercept, the first bracket, x minus 4. Our trinomial factor is x squared, and then our b is minus 2. Then it will be minus 2x plus the 4 there. Happy grade 12, we have a trinomial, the same as being using synthetic and the long division method. This is the short method that you can use. It is 100% correct. X minus 4, and then you are looking for the factors of this trinomial. You are looking for factors of 4. When you add them, they give you a minus 2 grade 12. Is it possible to get those factors? Now, let's check now. If we are taking our discriminant, b squared minus 4ac, Do you still remember your nature of roots? The b is minus 2 squared minus 4a1, and the c is 4. And then this is giving us 4 minus 16. So it will be the square root of a minus 12. Can you see grade 12? Your square root is negative. That means this part here is giving us non-real roots. We don't have x-intercept for this trinomial. You can write non-real roots because you are technical math learners. You can write imaginary. So this simply means now we have only one x value there, which is x equals to a 4. Only one x-intercept. Do you still remember when we started? I indicated to you that there's a condition where you'll be having only one x-intercept. There's a condition where you'll be having 2. There's a condition where you'll be having 3. This is the condition where we are having only one x-intercept. We have done the condition where we have 2. Why? Because the other x-intercept is a stationary point. It's a turning point. Okay, so the obvious one is where you are having all your 3 x-intercept values. Let's continue now. Determine the stationary points of G now. If we do stationary, do you still remember you need to derive your function? This one is on the correct condition. There's no need to multiply anything. Minus 3 times negative 1 is negative 3x. You subtract 1 to the exponent to the power 2. 2 times 6, that is 12, x to the power 1. And then this one, you take the coefficient, it's minus 12. 6, derivative is 0. And then you let this equal to 0. And then this side we can divide by minus 3 throughout because it is possible to do so to simplify your equation. Minus 3 goes once, you are left with x squared. Minus 3 into 12 is minus 4x. And then minus 3 into minus 12, that is positive 4. So we are looking for factors of 4. When you add them, they give you a minus 4. That will be x minus 2 and x minus 2. Can you see it's 2 brackets of the same thing? There's no need to repeat. We will only write x equal to 2 for that one. Great job. Look at this. It's very critical here because you are now having only one stationary x value. Pay attention. We are having only one x stationary point. Previously, we were having 2 for all the functions that we have done up to so far. And then now, if we have 1, let's see what will happen now. To get the y value, do you still remember? We take this y turning point x value and substitute into original. We are now substituting 2 into the original equation plus 16. And then this straight into your calculator, grade 12, it must give you the value of 8. Okay, that means now our y turning point here will be 8. So when we coordinate this, our turning point will be 2 and 8. We can't tell whether is it the maximum or the minimum turning point because this is the only turning point that we are having. Let's see what is going to happen, great job. And then now move to 3.4, sketch that particular graph. Okay, remember you need to identify the shape. It's very important. In this case, our a is less than 0, meaning it is negative. So we are expecting a shape that is finally down or a smooth curve like that one. Okay, that is the first thing. The second one, we need our y-intercept. We have just calculated above that y is equal to 16 with coordinates 0 and 16. It's our y-intercept. And then we have also calculated the x-intercept of this particular function. And then we ended up with x equal to 4 as being one of the factors of the x-intercept. That is x equal to 4. And then now, remember when we were trying to find a trinomial factor for this one, the other part was non-real. So this is the only x-intercept that we are having on this particular function. Now we try to calculate the turning point also. The turning point or stationary point is giving us only one stationary point, of which is coordinating 2 and 8 there. So that is all we need. We have all what we need. Let's see now, how do we sketch this surprising function graders? Right, y-intercept is positive 16. The x-intercept is 4. The turning point is at 2 and 8. That is coordinating there. Those are the only points that we have. I have indicated everything there. Those are the only points that we have. But we know at this point, this graph is turning. It's a stationary point at 2 and 8. And then now, this will be the graph that we are having. Coming this way, cutting at 4 there, it must pass through 4. And then this is your x and y axis there. So is this type of a smooth curve, grade 12. This is how you sketch. And then how do you know now? Because it can't be a straight line. Most of the learners are just joining those points and forming a straight line. No, it can't be a straight line because these calculations are from a cubic equation. Therefore, it must be a cubic polynomial function that you are having. Hence, this shape notation here, predicting your shape, will assist you in terms of sketching the correct graph with only those 3 points, grade 12. I hope we are together on this one. The first mark will be for the y-intercept, the second one for the stationary point, for the x-intercept, for the y, for the x-intercept, for the stationary, and for the shape. So this problem with 4 marks, grade 12. That's sketching. Okay, I hope now you know what to do with the sketching of your functions there. All right, I would like you to try this one, grade 12, on your own. We are calculating the x and y intercept, coordinate of y-intercept, determine the x-intercept of this function, and then I am adding 4.3 here. Look at the stationary point, that means you'll be looking at the turning point, and then 4.4, you sketch the graph for me. So that is your activity, grade 12, for 5 minutes, starting now. Okay, grade 12, let's see how far did you go with this one. Remember our WhatsApp number, 079-578-2908. That is where you can send your solutions or your clarity-seeking questions or any alternative method. Remember, we said there is synthetic, there is long division method that you can use to find your x-intercept. Okay. Now, the first question here, you need to determine the coordinate of the y-intercept. We know that to find the y-intercept, grade 12, what do? You let x equal to 0, okay? Y-intercept, we let x equal to 0, okay? We are having our function here, y equal to x minus 1 cubed minus 1. Then we let x equal to 0, y will be equal to 0 minus 1 cubed minus 1 into your calculator. This is giving you an answer of minus 2. So if they say in coordinate form, x is 0 and y is minus 2. That is your y-intercept, grade 12. 2 marks for that. And then 4.2 is 1 mark for substitution and 1 for the minus 2. Or they can mark it at the level of coordinate there, 0 for x and the minus 2 for y. And then 4.2, determine the x-intercept of this particular function. We also now know that now x-intercept, we let y equal to 0. So we are having our 0 is equal to x minus 1 cubed and minus 1. So we need to solve for x greater on this one. So we are going to start by taking minus 1 into this side. It will be positive 1 equal to x minus 1 to the power 3. If this side loses an exponent, this will gain a cube root of 1, and then you'll be left with x minus 1. What is the cube root of 1? It is 1. X minus 1. And then minus 1 to the side, it will be positive 1. Therefore, x is equals to 2. That is your x-intercept. In coordinate form, it will be 2 and 0 there. That is your x-intercept. So the next activity here, you need to look at the turning point of this graph. Now, to determine the turning point or the stationary point of this one, remember you need to derive that. You can't derive if there are brackets. So you need to multiply those brackets out, grade 12. That is your first thing to do before deriving or differentiating. So this means we are having 3 brackets of x minus 1. So that is x minus 1 into x minus 1 into x minus 1. And the minus 1, that is out of the bracket there. So now let's multiply our brackets. I'm going to leave the first one and concentrate on these 2. Then I'll come to this later on. So that will be x times x squared. X times minus 1 is minus x. X times minus 1 minus x. Minus x minus x minus 2x. And then the last term, minus 1 times minus 1 is a positive 1. Remember, this is inside the bracket. Don't forget the negative 1 that is out of the bracket. Now I am bringing in x minus 1 distributive law, multiplying by x. Now x times x cubed. X times minus 2x squared. X times 1 plus x. Multiply with minus 1 now. Minus 1 times x squared minus x squared. Minus 1 times minus 2, positive 2x. Minus 1 times positive 1, negative 1. What is the next step, grade 12? We are looking for the like terms. So x cubed is the only one. And then no partner for that. Minus 2x squared minus x squared is giving us a minus 3x squared. And then we have a plus x plus 2x, that is a plus 3x. And then minus 1, no partner for that one. Then that is the only constant we have then. Now our equation is at the standard form, original standard form, we can now derive. Remember, the notation is dy dx, deriving y in terms of x. Then is 3 times 1, that is 3x minus 1 from the exponent to the power 2. 2 times minus 3 minus 6x minus 1 from the exponent to the power 1. If x is to the power 1, we take the coefficient plus 3. And then if this is a constant, derivative is 0 then. Okay, and then we let your derivative equal to 0. And then now you solve for x on the right hand side. You can see it's possible to divide by 3 to make this simple. Or you can use your quadratic formula, it's fine. 3 divided by 3 is 1, x squared. Minus 6 divided by 3 minus 2x. And then 3 divided by 3 is a positive 1. So factors of this are x minus 1 and the x minus 1. Even if you use your quadratic formula from this step, you'll end up with the same x values. And then these are the same x values, so x will be equal to 1. Do you still remember grade 12? Why is it giving us the same values then? That means we have what? One stationary point. Hence, we have only one x turning point there. So now, after finding the x turning point, we must also find y by substituting this x into original. Let's do so. Y is equal to our x turning point is 1 minus 1 cubed minus 1. We are now substituting this x value into our equation there. And then into your calculator, grade 12, this one will give you a minus 1. Therefore, the turning points for this graph is 1 and minus 1. And this is the only turning point now. Okay, only 1 instead of 2. We can't tell whether it is maximum or it is a minimum turning point. Now we need to sketch the graph, grade 12. We have identified the shape will be positive because the graph A value is greater than 0, meaning positive. So the graph is either going to be like that. Obvious, if it is having only one stationary point, that means it's a positive one. Okay, smooth curve like that one. It can't be that one because there is only one stationary. So we are looking for this shape. Okay, and then now that is the first step. Number 2, we need our y-intercept. We have just calculated that our y-intercept will be equal to minus 2, which is 0 and minus 2 in coordinate form. Our x-intercept, we have calculated that the x-intercept will be x equal to 2. That means now this is 2 and 0. That will be the only x-intercept. We have only 1. And then now we have just calculated the turning point that it will also be only 1 turning point, of which it will be turning at 1 and minus 1. Now we have everything that we need, grade 12. 1, 2, 3, 4. All what we need is there to sketch this particular function. And then now we can indicate y-intercept is minus 2 AP. That is our y-intercept. X-intercept is positive 2. That is the minute you say intercept, it must be on the axis line. Okay, these two, it must be on the axis line. This one is coordinating. It's a pair. It goes together. They share. Okay, where are they sharing? At 1, x1 and y minus 1. So they will alternate and meet there. Okay, can you see, grade 12, with those 3 points, it is very difficult to draw the graph unless you have predicted initially the shape that you are looking for. Because most learners, they just draw a straight line. It is not a straight line, it's a cubic function. So it will be a cubic coming this way towards this, and it will turn there and go down like that. It's a smooth curve line. So 1 mark for the x-intercept, 1 mark for stationary, 1 mark for y-intercept, and the last mark for the shape. Therefore, sketching of this function, it worth 4 marks. Okay, we are done with the sketching, grade 12. I hope you managed to get your full marks on this particular activity. Now we are moving on to the interpretation of the cubic function. So the first question says that the graph of h at x, ax cubed plus bx squared is drawn on the right hand side, yeah? And the graph has the turning point at the origin 0 and 0. That is our turning point. Can you see? Is the intercept? It's also a turning point. And then it is having another stationary at B, this point here, of which is 4 and 32. And A is a x-intercept. A is that point there. We don't have values for that point. Okay. And then now they say show that A is -1 and the B is equal to 6. Great. If you look at this, we have two unknowns. We have unknown A and unknown B. So the mistake that you do mostly, you take these values and substitute into the original. You can't do that, grade 12. These are the answers that you must get after showing us. So it's like I'm giving you an activity to solve for me. After solving, these are the answers you must get. You can't take these answers and substitute because you need to show me this is true or not. Okay, so we are holding this now, putting it aside. We are depending on our equation and the given information to find the value of A and the value of B. So if we look at the diagram, we have stationary there, that is 4 and 32. So we are going to depend on that point to assist us to have two equations because we have two unknowns. Now, we are going to treat this point as a point 4 and 32. Secondly, we are going to take it as a stationary. The minute we take as a stationary now, this B coordinate will be 4 and 0 because when we calculate the x turning point, we let the derivative be 0. That is why we are saying we take 4 and 0 for stationary. Okay, I hope that is clear. Let's start now. We are taking h at x function and then we use the point 4 and 32. So x will be 4. That is a into 4 cubed plus b into 4 squared. And then h at 4, our y is 32 there. Remember, this represents y grade 12. So we are putting a 32 there. And then 4 to the power 3, that is 64. A plus 4 squared, that is 16b. So this is our equation, grade 12. And then from here now, we can simplify this and divide by 16 throughout. So each and every term divide by 16, 16 by 16. So 32 divided by 16 is 2. 64 divided by 16 is 4a. And then 16 into 16 only once, then it will be 1b there. And then now we make b subject of the formula. We transpose 4a to the left. It will be 2 minus 4a this side. So that is our first equation there. Happy? We now have at least one equation now. We need the second one. For the second one, we are going to treat this point as stationary now. That means this works only if it's a derivative, okay? So now we are going to derive our function. Remember, to find the stationary, you derive. So it will be derivative of h at x is equal to 3 times a, that is 3a. Same method, ax, subtract 1 from the exponent to the power 2. 2 times b plus 2b, x, subtract 1, it will be to the power 1. But because this is a stationary calculation, remember we let y equal to 0 there in order to solve for x. Do you still remember? And then now in this case, we are going to substitute that x that is given to us there. That is 3a into 4 squared plus 2b into 4. So now this will give us our second equation. 4 squared is 16. 16 times 3, that is 48a. Plus 2 times 4 is 8b that side. Remember, our b is 2 minus 4a. So wherever we have a b in here, we are going to substitute 2 minus 4a. So this will be 0, 48a plus 8 into 2 minus 4a. Or grade 12, you may start by simplifying this because you can divide by 8 into 48 and 8b. It's better to work with smaller values than bigger ones. So 0 and then 48 divided by 8 will give us a 6a, and then 8b divided by 8 will give us a b there. It will be plus b. Happy now? Now for b, we are going to substitute 2 minus 4a. All right, we have 0, we have 6a. For b, we are substituting 2 minus 4a. And then 6a minus 4a, that is 2a. And then this 2 we are transposed into this side, it will be minus 2. Divide by 2 both sides, therefore a will be negative 1. Is it true, grade 12? Yes. Now, happy, can you see why we gave you that answer? So that after calculating, you check, is your answer minus 1? You can't initially use what you need to prove, okay? And then now we need to also show that b is 6. We are going to take this a now. These are simultaneous equations. We will substitute a there to get the value of b. This will be 2 minus 4 into minus 1 equal to b. That is 2 plus 4 equal to b. Yes, happy. b is equals to 6. Therefore, that is correct, grade 12. The calculation is correct because it is taking you to the expected solution there. Now, what is the actual equation for this graph now? Our actual h at x function is h at x equal to a is minus 1, this is minus x cubed, and then b is 6, that is 6x squared. That was the original equation for this particular graph there. That is how you find the equation. And then now they say calculate the coordinates of a. Now we now know the actual equation of this is h at x equal to minus x cubed plus 6x squared, as we have calculated previously. Now if you look at a is the x-intercept of this function. To find the x-intercept, you let y equal to 0. Do you still remember that? Y is 0. And then on this 2, you have a common x squared. So we'll take it as minus there. So minus x cubed divided by minus x squared, you're left with x, plus 6x squared divided by minus x squared is minus 6. Therefore, the first x there will be x equal to 0, of which is this one. Okay? Or the second one will be x equal to 6. So they need this in coordinates. That means the a point coordinates will be 6 and 0 there. Okay. And then now they say here, write down the values of x for which h function is increasing. When you increase it, when your gradient is positive, going up. When it decreases, it goes down. The negative gradient. Up is a positive. So a straight line up is positive gradient, down is a negative gradient. At a turning point, it is stationary. You can't tell whether it's increasing or decreasing. So now we want to identify in this function. Remember, we know now this is 6 here. We want where the graph is increasing now. So this part is going down. That means the gradient is negative. So if it is negative, it is decreasing. Here, the graph is going up. From left to right, grade 12, therefore the gradient is positive. Therefore, this is increase. And then lastly, the gradient is going, the graph is going down, therefore gradient is negative. Okay, so the graph is decreasing. That is how you identify the decrease and increase part. Okay, when you increase, just remember, when you increase a money or something, you are adding something. When you decrease, you reduce, you are minusing something. Okay, so now we are looking at the increasing part first. So that means from this point here, within these two, it's where you are having an increasing part. Increasing part is here. So that means it's between which x values now? Between 0 and 4. We can't put inequality sign with equal to there. We can't say greater and equal, because now at equal, this is stationary. Okay, now this is the solution for increasing. For the decreasing part, we are having two solutions there. And then there's a gap in between. You have a decreasing part from here going this way, and the decreasing part from there going this way. So that means the first solution will be at x less than, because it is less to this direction, less than what value? X value 0 there. Or at x going this direction, it is greater than. That means greater than which x value? 4, because our x is 4 there. So those are the solutions for that. To get this, the first mark would be for the values, the second mark for correct inequality signs there. Okay, and then there is another notation here. You can write as x element of round bracket 0 to 4 there, and round bracket. And then this one, it can be x, but I prefer this one greater. It's x element of, it is less than, that means to negative infinity starting from 0, or x is an element of starting, x is greater than 4, it is starting from 4 up to positive infinity. So those are the two alternative notation that you can use, but preferably I prefer the top one. It looks easier for me, but when I choose the one that is easier for you, you are not restricted to any method, great jobs. And then the next activity, the graph of y equal to mx cubed minus 3x squared minus 12x plus n has a local minimum turning point at 2 and minus 3. And then determine the values of m and n. We are given only one point, of which is a turning point. So we'll treat this as a point, 2 and minus 3, and then as a stationary point, 2 and 0. Okay, remember I'm putting this to remind me that I need to derive before I can substitute that one. Let's start with the original 2 and minus 3. So our y will be minus 3. We are using our equation there for substitution. It's minus 3 equal to m, x is 2, cubed minus 3x is 2, squared minus 12x is 2, plus n. And then this is minus 3, 2 cubed is 8m. And then this is 2 squared is 4 times 3, that is minus 12. And then minus 12 times 2, that is minus 24, plus n. And then it's a minus 3, we have 8m there. And then plus n. And then minus 12 minus 26 is minus 30. Minus 12 minus 24 is minus 36. And then now we transpose everything so that we are left with only n this side. It will be minus 36 to this side will be positive 36 minus 3, that is positive 33. And then minus 8, positive 8m to that side will be minus 8n. So that is our first equation, because we are solving for m and n simultaneously. So to derive the second equation now, we are going to use the derivative one. We are deriving dy dx, deriving y in terms of x is 3 times m, 3mx to the power 2 minus 6x minus 12. Let it equal to 0. Then is 3mx, and then the x is 2 there, squared minus 6 into 2 minus 12. We are substituting this point here now. And then now we are having a 0. 2 squared is 4 times 3, 4, 8, 12m. Minus 6 times 2 minus 12, and that minus 12. So this is giving us 0 is equal to 12m minus 24. And then we transpose 24 becomes positive 24, 12m. Divide by 12 both sides, therefore m is equal to 2. Happy, we have the value of m. We can now take this and substitute in here to find the value of n. So it will be 33 minus 8 into 2 equal to n, that is 33 minus 16. And then this is giving us the value of n being 17. So happy grade 12, we have the value of m and n. So the actual equation here is therefore y equal to m is 2, that means it's 2x cubed minus 3x squared minus 12x plus 17. That is the correct equation of this cubic function. The diagram shows the graphs of f at x and g at x, and g at x is given as 2x plus 12, of which is a straight line 1. As you can see, straight line is g, and the cubic is f there. For which values of x is f at x less than 0? You need to understand what does this statement says to you. It says f at x, that means f at x is a cubic, right? Where the cubic is less than 0. Less than 0 means where the graph is negative. How do you know your graph is negative? Your graph will be negative below the x-axis. That means all these graphs here, they are negative below the x-axis. Your graph is negative. Why? Because the y values are negative here. Above, the graph is positive. All the graphs are positive there above because the y value is positive. Okay, now we are looking for f function where it is negative. So we are looking at the cubic function where it is negative. Is this part here, starting from here? Can you see this part is negative here? And then now this part is also negative for the cubic function. Now we are concentrating only on f. Right, now let's write the solution. It's from this point, and remember this graph is continuing to negative, goes down there. So it will be x going this way is less than what? X value minus 2. Or between these two x values, the graph is negative. That is between 1 and 6. The minute you say between, can you see my x is in between? Therefore, that is how you answer that particular question, grade 12. And then the 7.2, we are still on the same function. We are determining now when f at x it is greater than 0. That means we are looking at the positive solution of this graph now. Remember, it is positive above. We are concentrating only on f. F is positive above. That means this is determined by the x values there. We are depending on the x values. Right. Can you see it is positive between what? This part here. Can you see? Between these two x values. Okay. Between minus 2 and 1. Can we include? Yes, because this is included. It's greater and equal, positive and equal to 0. Okay. Now, we start having another positive part from this point to this direction. That means now all x greater than 6 is your solution. Happy grade 12. 7.3, where f is greater than g function. What does it mean? It means f must be above, g function below. So f graph must be above the g graph. We are looking for the x value where f graph is above the g graph. Let's check now. Okay, the f is above. It's from this point. Can you see this part? It's above up to here. Then here it starts to be below, and then it will be above again from that point here. And the coordinate for that point is 7 and 28. Then. Now, for which values of x? Can you see we have identified in this part here is between the x value 0 and minus 2. So that means between minus 2 and 0, it is where f is above. Or where when x is greater than 7, the graph is above the g. Okay. Here the statement say F times G is less than 0. The product of this is negative. When can this be negative? When F is negative multiplied by positive G, then your product will be negative. Or when this is positive and the G negative, then it will give you a negative product that you are looking for here. We are looking for the negative solution, not one, just negative. So now we need to compare the two graphs. Where we are having plus minus on the two graphs, it's where we are having a negative product. Remember, here is positive, and this is, sorry, this is negative, it's below. This is negative, negative, also negative here. Negative, 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 negative. Above, positive, 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 positive. Everything is positive up to this point. Now we are looking for plus minus. We can't take this part because it's negative, negative. Can you see that? And then we cannot also take this part because it is a positive by positive. So immediately after here, it is where we are having a negative times a positive, of which is what we are looking for. So now it continues up to this point here. Beyond this point, you start having positive, positive. Then our solution criteria, that means it's only here where we have a product being negative. That is x between only one solution, x between 1 and 6. There is no or, because it's only one portion on your graph. Okay. Moving on to 7.5 now. We are looking at the two graphs now being greater and equal to 0. They are both positive now. That means it's the portion that we have left. In order to be positive, they must both be negative. Then it will give us positive product, or both positive. It will give us positive, because negative times negative is a positive. Positive times positive is a positive. So, okay, Travis, where do we have both negative here? These two graphs are negative. Okay, here they are equal to 0. It's fine, because equal to 0 is also part of the solution. They are both positive. Yes, happy. They are both positive. Yes, but the minute you come here to 1, this is now negative and positive. They can't be our solution. That means our solution is within this interval here. Okay, continue now. Still having both negative, positive up to this point. So here, happy, they are both positive now, both positive. So our solution is from here to this direction. That means at x less than 1. Or the next solution will be after 6 here. That means it's x greater than 6. Those will be the two conditions where you are having your graphs being positive. Yes, creators, I hope we are still together. We are almost there. And then now we are having 7.6, where now the graph is less than, the f over g is less than 0. It means now when you divide the two, they must give you a negative solution. And then now when will these two graphs give you a negative? It's when one of it is negative and positive. Do you still remember? We had a condition whereby we were having, let me resketch again. Our graph is cutting there, going this way, and then to the stationary point we have it there. Okay, so they are sharing this point, is point of intersection. We are having 3 of them there. All right, and then now we are looking at the values where our graph is. Remember, this is 1, 6, and a -2 there. So where one is negative and the other one is positive, do you still remember? It's only this part. It is repeating itself in different ways. This is plus, minus. This can only be negative if one part is negative, the other one is positive. So it's between 1 and 6 grade terms. And then now to the next question, we are looking at f derivative. Derivative means the gradient of this must be greater than 0. Greater than 0 positive. It means look where the gradient of this graph is positive. The f function where the gradient is positive. That means where it is going up. Can you see that? Going up. We can't take this one because it's going down. So gradient is positive this side, it's also positive this side for the f function. Where does it start? So for the gradient, we use the stationary point to identify that. It will be from, this is negative 12, it can be positive, x is negative there. So it will be x less than minus 0.67 or at x greater than 6 from here to that direction, and then from not 6 grade 12, we are using the stationary, from 4. Sorry for that, it is from 4 here. Remember, for the gradient we use stationary point. For the positive and negative parts of the graph, we are depending on the x-intercept to identify that. I hope that is clear. We are still on the gradient. You are looking where it is negative. Going down is this part. Therefore, gradient is negative. So this is decreasing. Okay. So x is in between because it's between what? Minus 0.67 and then positive 4. Thank you, grade 12. This is the end of our today's lesson. This lesson was brought to you by Gauteng Department of Education with collaboration with the Bono Discovery Center. Thank you very much. See you next time.